Yeah, I attended.
Okay. How many did you all solve?
Three
Three
questions.
questions. Bro.
Okay. So this was problem A. For problem A, any one of you can unmute and tell.
Yeah, for problem I there will be always four types of number: 4n+1, 4n+2, 4n+3, and 4n. So 4n will satisfy 4n+3 type of a number, so that the mod is 3. Hence, there will be always four number of pairs if Bob has to win. In any such scenario, if there are total number of n, so doing the modulo of 4 means total number of n modulo of 4 gives us, if Bob wins, that there are all four numbers satisfying other pair of fours. Uh, that's how Bob wins, else Alice wins.
Yes, correct. So this question we can infer from examples. For example, if n is equals to 1, then we only have one element. So basically, first you are given a number n, and there is a combination of integers from 0 up to n minus 1. And after that, in one round, Alice chooses a number A, and then Bob chooses another number B, such that this condition holds true. That is, A plus B is equals to 3 modulo 4, and then erases it. And after that, they keep on playing in this way. And if one player who is unable to move, that player loses, and the other player wins. So n is equals to 100 in the maximum case. So this question you can solve from observation. Like for n is equals to 1, I'm only having one element, that is 0. So Alice in his first round picks up the 0, and then now my array is empty. So Bob cannot pick up anything. So for n is equals to 1, Alice is winning. For n is equals to 2, I'm having 0 and 1. So Alice picks up, if Alice picks up 0, then Bob cannot pick up 1, because 0 plus 1 modulo 4 is equals to 1, not 3. And if Alice picks up 1, then also same thing. Bob cannot pick up 0. So no matter whatever element Alice picks up, for this case, always Alice is winning. For n is equals to 3, so the elements are 0, 1, 2. So here you can observe that if Alice picks up 1, then Bob can pick up 2. Correct? Because then the condition is satisfying. But we are having a problem with 0. If Alice picks up 0, then Bob is not having any valid picks. So so suppose Alice picks up 1, then this 1, 2 I can consider as a group. Like if Alice picks up 1, then Bob will pick up 2. Else, if Alice picks up 2, then Bob will pick up 1. After that, if Alice picks up 3, and this 0 and 3 I am considering as a group. If Alice picks up 3, then Bob can pick up 0. If Alice picks up 0, then Bob can pick up 3. After that, after two round is completed, it is Alice's turn. But by that time, the array is already empty. So for this case, Bob is winning. For n is equals to 5. So if I consider groups like this, like if Alice picks up 1, Bob will pick up 2. If Alice picks up 3, Bob will pick up 4. If Alice picks up 4, then Bob will pick 3. If Alice picks 2, then Bob will pick 1. But 1, this 0 is remaining. This 0 could have been paired with this 3, correct? But this 3 needs to be paired with 4 also. That is the problem. So this 3 cannot do the pairing with two numbers. It has to do the pairing with only one number. That is why in this case Alice is winning. Similarly, you can go for n is equals to 6. We will go for n is equals to 7. And after that, for n is equals to 8, we will conclude. Now, for n is equals to 6, this 0 and 5 cannot form a grouping because 0 plus 5 modulo 3, it is 2, not 3. 0 plus 5 modulo 4, it is 1, not 3. That is why this cannot. See, for this case, we can do a grouping of 0 and 1, 0 and 7, because 0 plus 7 modulo 4, it is equals to 3. So the condition is satisfied. So in this case, Bob will win. So from this pattern, what can you infer? Anyone please unmute and tell. From this pattern, what formula can you get?
Yeah, modulo 4, which gives 3, can only satisfy modulo 4, which gives 0 kind of number.
Yes. If n modulo 4, it is 0, like n is equals to 4, n is equals to 8, then at these cases, Bob will win, else Alice will win. See, for test cases also, Bob is winning for this 4, Bob is winning, and Bob is winning for the last case, 100, which is also a multiple of 4. Is this solution clear to everyone? Uh, just a second. Yes. So I have taken input as n. If modulo 4 means it is a multiple of 4, then Bob is winning, else Alice is winning. Is this code clear to everyone? Okay. So we will be going to the next question. states that there is a array. A tournament is held with n players. Each player has a strength AI. While more than k player remains, then two players are chosen at random, and then the player with the lower strength is eliminated. And if they are having the same strength, then any one is eliminated at random. So J and K is given. What is J? J represents player J, and we have to find out that whether player J will be one of the last seven survivors or not. So, what was the approach for this question? Any one of you discuss your solution? Any one of you unmute and tell what approach we have followed for this question. Uh, you can also type in chat box if you wish. So, one of the things,
I
yes,
don't actually remember completely, but how much I remember from it was that after all the matches, there will be only two people remaining. Like if uh, if the guy, if J isn't the strongest, then there will be two. If J is the strongest, that is J has the highest points, then only J will be remaining. So we need to see that K is greater than 1. If K is greater than 1, then we can always get like the right answer. Or else if K is equal to 1, then we need to see that J is strongest. That is J is maximum in that array. This is what I remember.
yes, correct. We can break this question into two cases. One of the cases where k is equals to 1. When k is equals to 1, then only one person will remain. Okay, so for k is equals to 1, only one person will remain. So if only one person is remaining, then that last person must be player J. So when can player J remain till the last? If his strength is the highest among them. But here also two conditions come. Means player J is the strongest, means no other player has strength equals to AJ, then automatically player J will only remain. But another condition can be that other players also are there whose strength is equals to AJ. So for that condition, it is said that we will choose any player at random and then eliminate that player. So if the other player strength is also AJ, then I will be eliminating the other player instead of eliminating player J. If I eliminate the other player instead of player J, then till the last my player J will remain alive. So for k equals to 1, we need to just check that the strength of player J is the highest among all the strength or not. And for k greater than 1. So for k greater than 1, one thing is that my highest strength player will always survive till the last. So isn't it a good idea that I will eliminate other players using the high strength player? For example, uh, k equals to 3, 3, 2, 4, 4. 1. So k is equals to 3. So till the end, my three players must remain, and my j is equals to 2. Uh, n j, and my j is equals to 2. So player with strength 2 must remain till the end. So I can see that my highest strength player is 4. So I will be choosing two players at random. So let me first choose 4 and 1. And after 4 and 1, 1 is eliminated and only 4 will remain. So my array becomes 4, 2, 4, 4 only. After that, let me choose 4 and 3. So 4 and 3, 3 will be eliminated, 4 will remain. So 2, 4, 4. See, k is equals to 3 and I am having 3 players remaining. So with the help of my high strength player, I will try to eliminate other elements such that the remaining elements which I get, among them only player J is included. Is this logic clear to everyone? Okay, so I will share the code with you. So I have taken n, j, and k as input. I have taken the array as input. After that, I have created another array B. I have copied array A into B, and then I have sorted B in descending order. After that, if k is equals to 1, if my jth player, see, j is one base indexing, but in arrays we do zero based indexing. That is why I am doing j minus 1. If j minus 1 is equals to b of 0, see, b is sorted in descending order, so b of 0 will contain the highest strength. So if my jth player is having the highest strength, then I'm printing yes, else I'm printing no. After that, uh, if k is greater than 1, then I'm saying that it is always possible to keep a player j alive. That is why I'm printing yes. Is this code clear to everyone? Okay. So the next question states that there is an array A of distinct integers. In one operation, we may choose a prefix and replace it with the minimum value. Means prefix will be replaced with minimum among. We can also choose the entire array A and do any one of the operation. Means if you choose the entire array A, you can apply a prefix operation or a suffix operation. For an element AI, there exists a sequence. Okay. For each element AI, determine if there exists some sequence of operation to transform A into AI. So for every index, I must check that is it possible to reduce my entire array into a array of length 1 such that the element in that array is AI, means the element at that index. If it is Any one of you unmute and tell what approach you have followed for this question.
So yeah, for this question, if we see the examples, there we can see the corner means left and right both will always have one. This is because if leaving that corner element, if we choose the whole array, we get a maximum or minimum depending on prefix or suffix, and then there will be two elements remaining. Then we choose the whole array, then we get using suffix or prefix, only the last one remains. So it will be always one, the corner elements. And for others, think of the middle element as A. We see including A from A to left till the starting. We sort it out and check if it is the minimum, then it will work. Or else, if inclusive of A, we check till the right and include means if A is the maximum, then it will work out because in that sense we can choose it, the suffix and
Uh,
prefixes.
okay, so uh, you said sorting, but for every index, if you sort, then you will get TLE,
Yes, yeah,
means the
actually
left.
I got TLE, then I did it with prefix sum and suffix sum. I used both of them, then I got them. Is my voice audible?
Is my voice audible now?
Yes, Bhaiya.
So for the ith index, suppose if there is prefix of I and there is suffix of I, so one of the operation is that I will be replacing the entire subarray with the minimum of prefix of I, or this subarray with the maximum of suffix of I. So suppose I am telling that if a of I is equals to prefix of I, or a of I is equals to suffix of I, then this means I can replace a of I, means I can replace the ith index with a array of size 1 whose element is also a of I. So a of I must be minimum from left, or it must be the maximum from right. For example, if I do a1, a2, a3, dot up to ai, and then up to an. So suppose a of I is the minimum element, means a of I is the minimum element from the left, means this subarray minimum element is a of I. So I will be choosing this subarray and I will be replacing with the minimum element a of I. And then for this a of I plus 1 up to this, means the other subarray, I have to replace it with the maximum element among the right subarray. So a of x is representing the maximum element from a of I plus 1 up to an. So now I am remaining only with two elements, a of I and a of x. So suppose a of I is the smaller element, then I can replace this entire array with prefix of this array, because means prefix minimum of this array, because that is only a of I. And if a of I is greater than, means a of I is greater than a of x, means among these two element a of I is the greater element, then I will be using the suffix operation. Among these two I will be replacing, I will take these two element as an entire array, and I will be replacing them with the maximum element which is a of I. So in this case I will get a array whose length is 1 and the element is a of I. So this was for when a of I is minimum from left. Another condition can be a of I is maximum from right. So suppose a1, a2, a3 up to a of I, and from I plus 1 up to a of n. So suppose a of I is the maximum element, and over here a of I minus 1. So a of I is the maximum element from the right. So this entire subarray I will take and I will be replacing with the maximum element from right. That is a of I, correct? And I will take this entire subarray from a1 up to a of I minus 1 and replacing it with the minimum element from the left. Suppose let it be a of x. I do not care what is the value of a of x. Finally, I will be getting two element. One will be a of x and another will be a of I. Suppose a of I is the greater element, then I will be taking suffix operation. Like if a of I is greater than a of x, then I will take the suffix operation. and then reduce it to a single element a of I. And if a of I is smaller than a of x, then I will take the prefix operation and then I will replace it with a single element that is a of I. Correct? So this was the case 2 operation where a of I is maximum from right. And you can prove that no matter what other operation you cannot do. Like if a of I is not the minimum from left and neither it is minimum from right, then you cannot do anything with a of I. Means at that position, the binary string must contain 0. Is this logic clear to everyone? Okay. So I will share the code now with you. So I have taken n as input. I have taken the array as input. See, now for the prefix and suffix operation, if for every index you keep sorting from 0 up to I or from I up to n plus 1 and then find out that whether that index is maximum or minimum, then for this maximum of minimum you will be taking big O of n, and this big O of n will be present inside another for loop. So then your time complexity will be big O of n square. So you will get TLE. So you have to somehow do the operation in such a way that your this minimum and maximum operation is done in big O of 1. So for this you can use prefix and suffix. So prefix of I will store the minimum element up to ith index. Like I created a prefix array whose length is n. Prefix of 0 is equals to a of 0 because at the 0th index the minimum is also 0th index, and after that from 1 till the end I am just doing prefix of I is equals to minimum of the present element and the previous element present in the prefix array. So this operation will give me means prefix of I will give me the minimum element at the ith index, and for suffix of I we will start from the right hand side and move to the left hand side. So suffix of n minus 1 is equals to a of n minus 1 because the rightmost element, that is only the greatest element if I consider all the right elements from the rightmost element. And after that from n minus 2 up to 0 I will go, and then I will do suffix of I is equals to maximum of a of I and suffix of I plus 1. So this will populate my entire suffix array with the maximum index from I up to n. So I've created a binary string. After that, I am checking for every element. For every element, is that element equals to its prefix? Means pre of I. Pre of I represents that minimum from the left. So is every element the minimum from its left, or is that element maximum from its right? If this is the case, then the binary string will contain 1, else the binary string will contain 0. And then simply you give the binary string as output. Is this code clear to everyone? Okay, so we will be moving on to the next question. So for the next question, this is also a game type of question. It is said that Alice and Bob is having a binary string s of length n, and there is integer k present. So Alice wins if all s is converted to zeros, and Bob wins, and if Alice is unable to win in a finite move, then Bob is winning. Means if it is happening that the game is continuing for infinite times, then Bob will win. So how will the play? In Alice turn, Alice chooses a subsequence. Subsequence means you will take a set of characters, but they need not be adjacent. Like I can choose these three things as my subsequence because they are a set of characters, but they may not be adjacent. So Alice will choose a subsequence of length k, and then she will replace it with zeros. So these three ones will be replaced with zero. And during Bob's turn, he will choose a substring of length k. And for substring, the letters must be contiguous. Like a substring of length 4 can be or this, or this in this way. So Bob will choose a substring of length 4 and convert it into all ones. We have to find out whether Alice wins or Bob wins. Alice will win if all the elements are zero at any point of the game. Means after Alice turns also, if the array is containing all zeros, then Alice will win. If it is containing all zeros after Bob's turn, then also Alice will win. And both the players play optimally. Means no player will try to make a mistake. So for this question, uh, what was the approach for you? Any one of you discuss your approach? At least discuss any one of the cases. One of the cases is very simple to observe. Can anyone tell any one case when Alice wins? Is the problem statement clear to everyone?
Yes,
So during contest, did you try to think any solution?
yes, I tried, but it was like, why won't they be stuck in a never-ending cycle? If it is 1100 and 11, and the subsequence means the sequence she chooses is sub-array she chooses is 11, then it becomes 00. But again, if Bob chooses it as the same 00, it becomes 11. Won't they be stuck forever doing the same thing?
Like suppose k is equals to over here n is equals to 3, 4, 5, 6, 6. So let us take k is equals to 3. So if k is equals to 3, then my 2 into k, that is 6. So your 2 in 2 into k is 6. So in this case, suppose k is equals to 3. So Alice will choose this to 1 and this 1 and convert it into zeros. So 0, 0, 0, 1. So 1, 1 is remaining. Now Bob will choose a substring this and convert it into all ones. After that, Alice will choose this these three ones and convert it into zeros. And after that, Bob will choose this substring and convert it into one. So in this case, for k is equals to 3, they will end up in a infinite cycle. So in this case, Bob will win. So for example, now if 2 into k is greater than n, so for example, if k is equals to 4, but over here we cannot take 4 because at that time instantly Alice can choose the elements. Suppose if I do 1 1 0 1 1 and now 0 0. So k is equals to 3 and n is equals to 1 2 3 4 5 6 7 8 8. So 3, no, I need to choose something less than this. Suppose k is equals to 1 and n is equals to. Okay, first let's break up into cases and then let us come to this thing. So one of the case was clear that uh, how Alice can win in the first move. Can anyone tell me how Alice will win right in the first move?
A is equal to n.
Yes, like if the count of 1 it is less than equals to k, then Alice will be winning right in the first move because she will convert all the ones to zeros. Correct? So now another case remain like this type of cases when Bob is winning. So for this, one of the observation was that after your means at first there must be at least k plus 1 once present in the array, because if k plus 1 once are present, then your Alice can convert only k ones to zeros, but 1 1 will remain, which cannot be converted. After that, I am telling that if 2 into k is less than equals to n, then always Bob will win. But why? So if 2 into k is less than equals to n, so after that I will get one remaining and some length of string. So if you go through the example, then you can observe that these length of string at least you will get k contiguous element whom you can convert to 1. And after that, whenever you give the turn to Alice, then you make it k plus 1, at least k plus 1 once, and then give it to Alice. Means every time Bob gives the array to Alice, Bob builds the array in such a way that there is at least k plus 1 once present. If there is less than k plus 1 once, then obviously Alice will win. So for example, let us take your examples from the test cases. It is not clear. Just one second. Okay, so the first example was 5, 2 and 1, 1, 0, 1, 1. So n is equals to 5, k is equals to 2. Number of ones is 2. So here I can see that 2k is equals to 4 and this is less than equals to 5. So in this case, I'm telling that Bob will win. How Bob will win? Because at first Alice will be converting any two ones into zeros. Now whenever Bob is getting the turn, I will simply convert these two zeros to ones. After that again Alice's turn, she will convert suppose this one and this one to zeros. 0, 1, uh, 0, 0, 1, 0, 1. Still now Bob can convert these two ones as these two zeros as ones. So 1, 1, 1, 0, 1. After that, Alice will again choose suppose these two ones, then 1, 0, 1, 0, 0. So after that, now again, Bob is having two contiguous zeros that can be converted into one. So in this way, the game will continue forever. Like if your 2 into k is less than equals to n, then Bob can continue the game infinitely. So let us see some examples where Alice is winning. So one of the example in test cases was 7, 4, and your elements were 1, 0, 1, 1, 0, 1, 1. So 2 into k is 8 and that is greater than your n because n is 7. So in this case, Alice will win. How Alice wins? Uh, Alice can convert four ones into zeros. 1. After that, your Bob will be converting four ones into your so Alice can choose optimally in this way. This one, this one, this one, and this one. Means Alice will try to keep one of the ones in the middle. So if I form my array like this after Alice's move, 0, 0, wait, four elements I'm removing, 0, 0, 0, and then 1. 1, 2, 3, 4, 5, 6, 7. Is this correct? So my array was uh, my array was 1, 0, 1, 1, 0, 1, 1, and my objective is that someone from the middle one must survive, so that when Bob performs the operation, then somehow he has to include that one. So because see, if 2k is greater than n, then either you can choose this half or you can choose this half. So this one I will make such a way that this one will survive. So I will be choosing these two ones and these two ones and convert it into 0. So 0, 0, 0, 1, 0, 0, 0. So this one is surviving. Now Bob has to convert either this entire substring to 1 and or this entire substring to 1. So whichever one he chooses, this one will be in must be included in Bob's move. So suppose if Bob chooses the first four elements and converts them into 1. So now in Alice's turn, I am not getting k plus 1 once. I can simply choose this 4 once and convert it into zeros. And then simply Alice will be winning. So the basic strategy is that when 2k is greater than n, then try to keep 1 in the middle if possible. So in that way, if Alice is try to do the operation in this way, then Alice will win. Else Bob will always win. For example, let us try for other test cases. So like the third test case was 6 1 0 1 0 0 0 0. So in this test case, k is equals to 1. Alice will simply take this 1 and convert it into 0, and Alice will be winning right in the first move. So let us take other cases like 4 1 1 1 1. So 2 into k, that is 2. It is less than equals to 4. So in this case, by my formula, Bob will win because Alice can choose this one and convert it into 0. Bob will simply replace it back. After that, Alice will again convert it into 0. Bob will simply replace it back. So in this case, the game will go for infinite time. So Bob will be winning. If 8 and 3, 1 0 1 1 0 1 1 0. So 2 into k, that is 6. 6 is less than equals to 8. So in this case, Bob will be winning. How Bob will win? Uh, Alice will take any three integers and convert them into zeros. Suppose Alice takes these three integers and converts them into zeros. So I can take any other three contiguous string which is 0 and then convert it into 1. Simply Alice is making number of ones as minus k, and then when it is Bob's turn, he is again making it plus k. So now it is 0 0 1 1 0. Now suppose if Alice tries to convert this 2 and this 1 into 0. 0 0 1 0 0 1 0 0. So convert it into 1. Then Bob's one move is wasted, but still Bob is giving Alice a string which is containing k plus 1 once. That is, Alice can not make this entire string into 0. She can choose any three string, but still one of the ones will be remaining. So whenever 2k is less than equals to n, then Bob is playing in such a way that give Alice the string such that number of your ones is greater than equals to k plus 1. So is this logic clear to everyone? Like, so it is breaking up into two of the cases. Case 1, when number of your ones is less than equals to k, then directly Alice will win. Case 2, if this is not satisfying, means number of 1 is obviously greater than equals to k plus 1. So if your 2k is less than equals to n, then Bob will win, else Alice will win. Is this logic clear to everyone? Or anyone has any doubt in this logic? Utkarsh, is this logic clear? Especially the case 2.
Yeah, as you said that when there is an infinite thing, then why does Bob win?
It is mentioned in the question. Sorry, my question is not visible. Just one second.
Sorry, Bhaiya, then I have maybe overlooked it.
Uh, yes, just a second. See, it is mentioned in the question. Like, uh, if Alice is unable to win in a finite number of moves, then Bob wins. Means if the game goes on infinitely,
Yes,
then
Bhaiya, got it.
automatically Bob will win. Yes. So is the case to logic clear? How
Yes,
Bob can make infinite moves? Okay, so I will share the code with you. I have taken n and k as input. I have taken the string as input. Uh, C is counting the number of zeros. O is counting the number of ones. Although the count of number of zeros was not required. So if it is 1, then 1 plus plus. If number of ones is less than equals to k, then directly Alice will win in the first move. If it is not so, and if 2 into k is less than equals to n, then Bob will win, else Alice will win. Is this code clear? Okay, so let us go for the next question. For the next question, did you try? How can we solve it?
no, Bhaiya. I didn't even
Okay,
read the question.
okay. So, uh, do you know what is max?
No,
Yes. So, suppose I am max means the minimum positive integer which is not present in that array. For example, 1, 2, 3, 4. So 0 will also be included in max. So the max of this is 0 because 0 is a non-negative integer which is not present in this array. Suppose 0 is present and 2, 3, 4 is present. So the max of this is 1 because 1 is the smallest non-negative integer which is not present in the array. Suppose 0, 1, 3, 4. Then the max of this is 2 because 2 is the smallest non-negative integer which is not present. Similarly, if 0, 1, 1, 3, 4, still the max is 2. For example, 0, 1, 1, 2, 2, 3. Then the max of this is 4 because 4 is the smallest integer, non-negative integer which is not present in, means smallest non-negative integer which is not present in this entire array. So, did you understand what is max?
yes, Bhaiya, got it.
Yes. So it is said that define max. Max means minimum excluded value of an array to be the smallest non-negative integer not present in the array. For example, this. So the main part of the question is that you are given a array A of size n of non-negative integers. You are performing operation, removal operation. So basically, you are removing k elements from the array and finding out that how many possible mixes are possible for different types of removal of those k elements. Like if I remove one element, so this one element can be any element of the array. So for different elements, how many different types of mixes can I get? So I have to return an array. For example, k is equals to 0, means I will be removing 0 elements, and by removing 0 elements, how many mixes can I get? For k is equals to 1, I will be removing one element, and how many mix can I get? K is equals to 2, means I will be removing any two elements, and how many number of mix can I get from this? So how can you solve this question? So one of the thing is that you can observe something from the sample cases. Can you tell any observation from the sample test cases? Anything which you can observe from sample test case?
One extra mix is always there. Means if there are four inputs in array, then there are five mix.
Uh, no, that is not the case. For example, see the first array. So one thing is clear for mix, my this ordering of the elements in array does not matter. Correct? Anyone can be present anywhere because I will be taking the entire array only. So for this test case, I am saying so 0, 1, 1, 2. So what is the max of this array? 0, 0, 1, 1, 2. It is 3, correct? Because 0 is present, 1 is present, 2 is present, but 3 is not present. That is why the max is 3. So one thing, see, over here 3 is there, and from left to right, I am going from 1 up to 3. So one thing I got that from right to left, maybe that I am moving from 1 to 3, because all the test cases from here, they are from right to left, they are going in increasing order. Let us go for the second example. 0, 1, 2, 3, 4, 5. So the max of this is 6. So see the second example, I have moved from 1 to 6. Let us go for the third example. 0, 1, 1, 2, 2, 3. So the max of this is 4. See over here, I have moved from 1 up to 4. After that, the left part, what I am doing, that consider for a later discussion. After that, another example. 0, 1, 2, 3, 4. The max of this is no, 0, 1, 3, 4 only. 2 is not present. So the max of this is 2. So see 0 and 2.
One
It
and
has
two.
went, means from right to left. One of the pattern I can observe that it will go from 1 up to the max. Correct? So why is this happening? So first example, the last element analysis is very simple. The last element analysis is that my k is equals to n. So I will be removing n number of elements. So I will just be removing all elements. If I remove all elements, then obviously my max is 0. Correct? So that is why my answer is coming as 1. because only one different possible max is possible. Now consider k is equals to n minus 1. So I will, for k is equals to n minus 1, my only one of the elements will be remaining. Correct? So I will remove in such a way that for example, like 0, 0, 1, 1, 2, 4 elements I will remove. If I remove these 4 elements, then my max is 1. And if I remove these 4 elements, then my max is coming as 2. So I'm getting two different max values. Correct? Now for n is equals to 3. Uh, 0, 1, 2, 3, 4. N is equals to 3. Mm, K is equals to, no, K is equals to 4. So just 1 second. 0, 1, 1, 1, 2. Okay, K is equals to 4. I am having 0, 1, 2. K is equals to 3 because it is starting from 0 based indexing. So now I am having 0, 0, 1, 1, 2, and I have to remove 3 elements. So either I can remove these 3 elements, then I will be getting 1, or I can remove your these two zeros, then I will be getting as 0, or I can remove your two, this one, and this one, then I'm getting as 2. Correct? So for every possible element, like in this case, like for 4 was the max value. So when it was at 4, then I was considering the entire array, and then I was telling that the max is 4. After that, uh, not this case. Yes, like 1, 6, 5, 4, 3, 2, 1. So this last one was for max is equals to 0. This one was max is 0 and your max is 1. Similarly for this and this. So from right to left, we will be going in an increasing order from 1 up to the maximum max value. Correct? So my analysis stands for the left values. So for left values, one of the thing is that for the first element, can you see all of them are 1? This was one
Yes.
of the observation. All of them are 1, and after that, from right, like k is equals to 0. K is equals to 0 means I am not doing any removal operation. Then for that, my answer is obviously max of entire array. Only one max is possible. Now for k is equals to 1. K is equals to 1 means one removal I can do. So if one removal I can do, then I will try, like, if any element's frequency was equal to 1, then obviously I can make that element disappear, and then my array will be having a unique max. For example, 0, 1, 2, 3. For k is equals to 0, the max was only one possible, which was 4. Now, one removal I can make in the array. Suppose if I remove 3, then my max is coming as 3. If I remove 2, then my max is coming as 2. If I remove 1, then my max is coming as 1. If I remove 0, then my max is coming as 0. So how many number of one frequency elements are present? 4. And that is only the number of unique max. Can you observe this? Suppose if 1 was present 2 times. So if I remove 3, then obviously my max is 3. If I remove 2, then my max is 2. But if I remove 1, then still my max is 2. And if I remove 0, then my max is 0. Like this removal of 1, since two number of ones are present, that is why even if I remove one of the ones, another one can contribute to the max. Correct? That is why over here we got 4, but over here we got 3 unique max. So my formula will be such that answer of 0 will contain 1, which will be the entire array's max, and answer of I, this will be equals to answer of I minus 1 plus how many count, means how many elements of frequency k, and this I will go on to solve till this pivot, means if up like first my filling will be done from right to left. If suppose right to left up to index ind I have filled, then I have to go from 0 up to ind, and I will be following this formula to fill the elements. Correct? So now obviously one question comes up that we need frequency of the element. So you can create a map and store the frequency of those elements. And see over here another thing, how many elements of frequency k, and these elements must be such that the max is less than means the element must be less than equals to the max value. Correct? Means I will be creating a map which will be storing the frequency, and after that I will create a reverse map. Rever Basically map creates a number to the count, and reverse map, basically it maps count to the number, and this number must be such that it is less than equals to max. Is this logic clear?
Somewhat.
Okay, let me first share the code with you, and then again we will come to this discussion. See, I have taken I have taken the array as input. This map is basically counting how many uh, means number to frequency, means this map is basically storing the frequency of every element. After that I am sorting the array. After that I am finding what is the maximum max value, means in the if I consider the entire array, what max can I get. So basically I will be starting with 0. If a of I is equals to max, I will simply increase max with 1, like 0. If array contains a 0, then my max will obviously be 1. That is why I have increased my max with 1. If later on I get 1, then obviously my max will be 2. That then I will increase my max with max is equals to max plus 1. After that, if I get a 2, then my max will be 3. So this loop is just calculating your max. After that, over here, I have reversed the mapping. Means instead of doing number to count, I have done count to number. So I have iterated over the map. After that, iterator dot first, if it is less than equals to max, then only I am storing it in the reverse format. So basically, like reverse of 1, it means how many elements are present whose uh, frequency is 1. Like how many elements are present less than equals to max, which are having only one occurrence. If rev 2, it means that how many elements are present with uh, value less than equals to max such that they have two occurrences. After that, I have built answer n plus 1. I have kept index at the end. See, from 1 up to the max, I will be going on filling it like 1, 2, 3 up to max. That is why I have done answer of index is equals to I index minus minus. So I have filled it up to max. After that, my first answer of 0 will always be 1. Because when I am not removing any element, then the max will be the max of the entire array and only one value is possible for it. After that, from 1 up to index, see, because I have filled up to index plus 1 over here in this loop, so I will iterate up to index and then I will be filling the answer as answer of I is equals to answer of I minus 1 plus how many elements are present less than equals to max whose occurrence is I. Because if the number of occurrence is I, then I will be removing all the I occurrences, and after that I will be getting a unique max, and then I will be giving the output as output of answer. So is this code clear, or should we dry run with a sample example?
Can you try them?
Okay, so let us take the first question as sample. Just 1 second. So the first sample test case was 5 and the elements were 1, 0, 0, 1, 2. So the max of this is obviously 3, and then let me short it. So I will be considering this array, and my answer array is there till 5. So 0, 1, 2, 3, 4 up to n is equal to 5. Yes. So this is the solution. So for now, I will be going from the right to the left. So for k is equals to 4, I can make 4 removal uh, in this array. Uh, sorry, k is equals to 0 less than equals to n. N is equals to 5. 1, 2, 3, 4, 5. 0, 1, 2, 3. Oh, like k will be just one more than this because question states that I k is greater than equals to 0 and less than equals to n. So k is greater than equals to 0 and less than equals to 5. So from 0 to 5, that is n plus 1 elements you will be having. That is why we had defined the answer as means the size of answer was n plus 1. So for k is equals to 5, 5 means I will be removing all the elements. So if I remove all the elements, I will be left with the empty array. The max of it is 0 and no other max is possible. So the answer for 5 is 1. Now for 4. So for 4, how means I will be removing 4 elements from my array. So if I remove 4 elements, then either I can remove these 4 elements, or then if I remove these 4 elements, then I get my answer as 1. Or if I remove your these 4 elements, then I get my answer as 0. So then my number of next is 2. After that, for n is equals to 3, k is equals to 3. So for k is equals to 3, I make 3 removals. So if these 3 I remove, then obviously one of my answer is 0. The other answer for me is that if I remove these 3, then my one of the answer is 1. One more answer is that if I remove this 0, this 1, uh, and then 0, 1, 2, 0, 1, 0, 0, 0, 1, 1, 2. So the max of it was 3. So 0, 0. So 3 removal. Another, how can we remove? If I remove 3, then again I get 1 only. If I remove 0, then I get 0. If I remove 1, so if I do like this, remove 0, 1, if I keep 1 remaining, uh, how can we find another value of max, like 2, etc.?
Remove
Or
one
from
zero one 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 two.
0, 1, then like 0, 1, 2, I have to remove 3 elements.
Remove the two. It will become two then.
Oh, yes, correct. Yes, if I remove the 2, then automatically my max is becoming 2. Correct. So 0, 1, 2, I got 3. So from the right hand side, is the operation clear? That
Yes, yes.
how can we get from 1 up to the highest max? Or from the right hand side, any doubt is there?
No, bro.
Okay. So till this, the answer will be from 1 up to max in increasing order. So for the left part, for 0 removal, obviously my answer is 1. I will not be removing any element and my max will be equals to 3. So now for k is equals to 1, I am telling that answer of I mean is equals to answer of I minus 1. I minus 1 was 1 because I made one removal last time, plus how many element is having count 1? Only 2 is having count 1. So if I remove this 2, then basically I am getting, correct? So 1 plus 1. Like over here, which all operations we can perform? We can remove any one element. If I remove 1, still I am not getting any advantage. If I remove 0, no advantage. If I remove 2, then obviously I am getting one of the advantage, then I am getting another max. That is max is equals to 2. But if I remove 0, then my max remains as 3. If I remove 1, then also my max remains as 3. So
Yes, Bhaiya.
by one removal, only two possible maxes we can get, 2 and 3. That is why my answer is 2. Now for k is equals to 2, k is equals to 2. So we will be removing two elements, and by my formula, answer of I will be answer of I minus 1. I minus 1 was 2, plus how many elements are containing frequency 2? Two elements. So it is equals to 4. So my k is equals to 2 will be having 4 max values. So 0, 0, 1, 1, 2. So I have to remove two elements. So if I remove your this one and this one, then my max remains as 3. If I remove your this 0 and this 0, then my max becomes 0. If I remove two ones, then my max becomes your 1. If I remove this 2 and any this 1 also you can remove, or this 0 also you can remove. Either you remove 1, then also you will be having max left as 2. If you remove your this 0, then also you will be having your max left as 2. So how many unique max we are getting? 3, 0, 1, 2. So we are getting 4 unique max. So for k is equals to 2 removal, the answer, my answer is 4. And for this, the answer is 2. Now, is it clear? How are we
Yes, Bhaiya.
feeling from right to left? Okay. So any more doubt in this question?
No, Bhaiya, no doubt. Bhaiya,
Okay.
can you tell me that while where you wrote the code, why there were so many things written in the above -1, 0, left, up, down, no comments or these things, or unsigned?
Acha. Okay. Just 1 second. So basically, uh, for competitive programming, I follow a template. Like every time you have to include these things. Every time means many things are there which you have to write. Like for competitive programming, speed is an essential thing. Correct. So if I have to write long, long, so it is not possible for me to always keep on typing long, 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 long. That is why you can just define LL as long, long. So next time, whenever you use long, long, just type LL. After that, many of the things which are most commonly used, you can keep them in your template. Like FF means first, SS means second, INF means infinity, which means int max, SZ means size, RTN means return, VI means vector int, VVI means vector of vector int, VLL means vector of long long, etc. PB means pushback instead of every time typing pushback. Also,
Yes, Bhaiya, got it.
endl, yes, and another thing you can do that you can keep some of your functions pre-built. Like for modular arithmetic, many times you will be requiring uh, a to the power b. You will be requiring fast exponentiation. So if you type the code during contest time, you will be taking time. That is why you can write the functions from first only, for power, for multiplication, for modular addition, for modular subtraction, for modular inversion, etc. Uh, and then also some of the codes which you feel that could be useful later on. Like I felt that the count for counting inversion uh, by merge sort technique, this could be used later on. That is why I had kept this. Many times for direction problems, you will be using this array template. Basically, -1 0 means in row you will go to -1, but in column you will be remaining in that column only. So obviously that is up operation, correct? So 0 - 1 means row you will be remaining in that row only, but column you will do -1. So you are moving to the left. So over here that direction part that I have pre-written. And over here many times in grid question you must check that whether your that index is a part of the grid or not. That is why I have
It's
kept
not,
this
it's
function.
not going out of bound or something.
Yes, that ij must not go out of bound. So these things you can keep pre-built in your code so that during contest you can save some time. Like you do not need to write vector of int. You can simply write vi. But if you
Yeah,
do
can you
such
also
things,
just tell that how
yes,
do we take means input a file and make a different
uh,
output file for the code?
yes, I do not take it using file. Like my inp of a, it is simply a function. Like my a is having size as n. So inp of a means I will be calling this function. Uh, Somewhere input function must be present. Just 1 second. Yes. So over here, like inp will just fill my array up to that part. So basically, I do not take input output from files. I simply take it from the means the console only over it. Although you can take it from file. Uh, which editor do you use while coding?
VS Code.
VS Code. For VS Code, you have made the setup for CP, or uh, you just type your code, then copy the code and paste like that.
No, but it's regular. I just upload the file after saving.
Uh, so is your VS Code something like this? Just 1 second. So have you made this type of setup in your VS Code?
No, bhaiya, it has the Explorer thing open where I normally save all the files, not this thing.
Okay. So you can create this type of format using VS Code. Basically, uh, for any problem, could you see the plus mark over here in
Plus
the
extension.
tab? So simply if I do plus over here, then automatically my question loads in my VS Code along with the test cases. So simply I can write my code over here, and then simply I can do run all and then understand that whether my code is giving correct answer or not. And if it is having a syntax error, then your terminal will open. For example, if I do like println, so simply if I do like this, obviously this will give a wrong answer. see, so directly it will show that this has failed. This was the expected output, but your output was this. So this setup is helpful for competitive programming. You can see any YouTube video and then make this setup.
Okay, bhaiya, I will see any tutorial or something.
Yes. Any more doubts?
No, bhaiya. Thank
Okay. So we are ending the PCD over here. Thank you, everyone. You all can leave the meeting.